So it says the sequence with the recurrence relation given here, and interestingly, we haven't been given this value p in the recurrence relation, and we're told that the first term is equal to 5, and we're told that p is a real valued constant. Okay, so it shouldn't involve I, but it says given that the sequence has a period of order 3, find the value of p. So we've been told that the period is 3, sometimes it's phrased as the period of order 3, which means the same thing. We need to find the value of p. So let's write this out in terms of my U notation. We know if the period is 3, then if you take any term in the sequence, which we'll call uk, it's going to be equal to the term 3 later. So k plus 3, like that. Now, if we consider the terms given in the question, well, we've been given the first term. Okay, so u1 is equal to 5. Well, 5 must also be the value of the term 3 later on. So that would be u4, okay, because we'd increase our subscript by 3. So what I'm going to try and do, in order to figure out what p is, I'm going to have to find an expression for the fourth term of the sequence using my recurrence relation, and then equate it to 5, which is what it should be equal to if this sequence has a period of 3, which we're told in the question. So we know that u1 is equal to 5, which I'm going to write here. Now, to find u4, we're going to have to find u2, then u3 first. So u2 is equal to, and let's substitute 5 into my recurrence relation. Okay, so that's going to go in place of the uk, because the idea is if we take uk, any term in the sequence, multiply by p, and then add 13, that's going to give me the next term in the sequence, which is going to be my second term in this case. Okay, so we are going to do p multiplied by 5, and then we're going to add 13. And then let's simplify that, so I would get 5p plus 13. So that would be the second term in my sequence. Now let's find u3. Well, now I have to substitute u2 in place of uk in my recurrence relation. So we're going to write out the right-hand side, but in place of uk, we're going to put 5p plus 13. So I would have p multiplied by 5p plus 13, which we need to put in brackets because it's multiple terms. And then we've also got the plus 13 at the end. Now, if we simplify, we get 5p squared plus 13p plus 13, like that. So that's my third term. Now we need to find u4, which is the crucial one for finding p. Okay, so what I'm going to do now is replace the uk in my recurrence relation with the 5p squared plus 13p plus 13. So I would have p multiplied by uk, which is this expression here, so 5p squared plus 13p plus 13, like that, close brackets, and don't forget about the plus 13 on the end. And then let's simplify, so we get 5p cubed plus 13p squared plus 13p plus 13. Okay, so now let's make use of this key fact up here, the fact that u4 is equal to 5. So what I'm going to do is equate my expression for u4 equal to 5. Okay, so I'm going to write 5p cubed plus 13p squared plus 13p plus 13 is equal to 5. And then I'm going to subtract the 5 in order to make that side 0. So we'd get 5p cubed plus 13p squared plus 13p plus 8 equals 0. And then we've got our cubic in the right format, so I can make use of the calculator function to solve it. And I get that p would be equal to negative 8 over 5. And that is the only real valued solution. The other ones involve I. And in the question, they said that p is a real valued constant. So p equals negative 8 over 5 would be the correct answer.